Hello, welcome to this TSConf workshop. We are going to be talking about the NoSQL single table design with TypeScript. First, let me introduce myself. I am Nataly Rocha. I'm from Quito, Ecuador, and I am a software developer at Stack Builders. To talk a little bit more about me, I can tell you some of my hobbies. I play the guitar, I have a band. I also like to play soccer, and I am an event planner, so I like to help people to plan parties. Yeah, but most of the time when I am not into my hobbies, I like to code. I've been coding with JavaScript for a long time, and I was recently introduced to TypeScript when I entered to work at Stack Builders, and I can tell you that it has been a journey. Here we like to apply all the best practices for programming. So TypeScript has helped us a lot to keep ourselves in that path. So we can make our code more readable, sustainable, and it basically lets us work a lot more comfortably and faster. Awesome. So let's check a little bit more about the agenda. What are we going to be covering in this workshop? First of all, we're going to check what is the single table design, why or what for should we use it. We're going to be creating a single table DB schema, making some comparisons with the relational database to give us a better idea of how it works. We're also going to check how is TypeScript going to help us with it. After that, we're going to start coding a little bit. We're going to configure our project. We are going to make our T setup. We're going to see how the API is made. We're going to make our table type safe, and we're going to use our types into the front end with some cool features from TypeScript. Yeah. So the single table design, what is it? First, to give us context of what are we going to be building and talking about in this workshop, we have to start to think serverless. Yeah, so we are building a serverless application, and here is where the single table design comes in. The single table design is used in NoSQL databases, and it has come popular in the past years, especially using it with DynamoDB. And NoSQL databases, as you know, they can be really flexible, highly scalable. They can even be cost efficient. They can have extremely high performance, but they do sacrifice some benefits in comparison with the relational databases. Like, for example, the normalization and the beautiful joins. We're going to be checking that later. So we don't have joins. And even if we want to resemble a join into a NoSQL database, this is going to cost us because the joins require a lot of CPU process. So how do we solve this? Basically using the single table design. So what we do to solve the problem that we don't have joins into NoSQL into the NoSQL database is pre-joining the data to create items collections that can help us get our data in a more efficient way. Okay, so having this design has a lot of benefits, and it basically helps us to retrieve our data a lot more efficient and let us use the relational mindset. Okay, the main benefit of using it is to decrease the number of requests that we make to retrieve our data. What do you think is this? Let's think about it. we can use the exact same relational database model into a NoSQL. You can create many tables with all the entities, with all the relations, and nothing stops you. But what happens? Let me show you this graphic. So let's say that the user is trying to get the information about their orders. Okay, so it goes to the server, and the server has to go to one table to fetch the user, then return, then go to the orders table, return the orders, and go back to the server, and then go to the user. So when we are talking serverless, this means that we're going to have many instances of our NoSQL databases, and this is going to cost a lot of time into our network. So we go one table, we go to the other table, and it can be kind of fast when we have two tables. But what if we have a join of 4 tables? So it gets pretty interesting. I'm not talking about like a 20 minutes wait, but in network it does cost us some milliseconds and seconds. Okay, so how do we solve this again with the single table design? We basically have one table. So what we do, the user goes to the backend server, goes to the single table, fetch the user and orders, go back, and shows it to the user. So it's that simple. And as I told you before, no one stops you from using the multi-table design, but you have to take in mind that you can try this single table design, and it's also a best practice for all OLTP applications. Okay, so let's talk a bit more about the benefits. So we're saying also that it saves us money. Why? Because if you think about it, when we used the relational databases, we started using them because the storage was really expensive. But now the storage is really cheap, and also we have enormous amount of storage, of data to store. So right now the storage is not a problem. The problem is the processes, the CPU processes that you have that are expensive. So if we start using, for example, the single table design, that we have pre-joined data and is going to give us the data in a lot more efficient way, it can save us a bit of money. Okay, also centralizing and monitoring the alarms to one table. So for example, if you have your relational model with multi-table design, you're going to have to set up the monitoring for all those tables. But if you use the single table, it's just one table to monitor and set alarms to. So it can be easier. Okay, so now that we have an idea of what the single table design is, it can be hard to change the mindset, but I do recommend you that if you're looking for a really affordable and highly scalable design, you can search a bit more for it. So I can recommend you the material from Rick Houlihan and Alex Debris. And well, let's continue to check our design. Okay, let's check our project. Basically, we're going to build a small serverless application that stores all the quotations that the client makes to a business. For example, this could be a car dealer. So many users go to the website, go and check the products, then make the quotations to see if they can afford the car. Okay, so it's going to be something really simple. So let's check our database schema. We have the products table. We have the that is related to the category and to the make. So the make is the main one. The make can have multiple categories, and the category can have multiple products. Also, the clients can have multiple quotations, and the products can have multiple quotations as well. So it's going to be really simple, as you can see. So how do we do to get this relational model to our single table design. First, we have to define our access patterns. This is the main process that you have to do before you start building a single table design. Okay, because basically you're going to put all the entities that you have in this relational model to one table. Okay, so you have to be really specific and clear of what the project is going to be doing. You have to go with the client to chat with him. Hey, you're going to need this report, this other report. Are you going to need to edit this or to delete? Because all the access patterns have to be very specific to start making the single table design. Okay, so let's start with products. So I would like to get the product by ID, by category, by make, and by quotation status. So as a user is what I want to see. So if I click a product, I would like to see all the information of the product. If I click a category, I would like to see all the products of that category, and so on. The same with the make. I would like to see the make by ID and all the makes. The category, I would like to see by ID. If I click as a user on a make, I would like to see all the categories that I have there, and all the categories as well. And as a client, for example, as an administrator, I would like to get all the clients and all the quotations that a client has made. And the quotations one is the largest one because it's the one that has the most relations on it. So as a user, I want to see the quotations by client, by day, by status, and so on. So even as with a date, because obviously as a user I would like to filter by date the quotations that my clients have made. Okay, so once we have defined these access patterns, the next step is to start building our single table design. So I have made this example. Okay. As I told you, this is going to be like kind of difficult to understand at first, obviously, if you don't know yet about the single table design, but bear with me. Okay, so for example, the single table design works with two main keys. The first one is the partition key. You can even make the table only with a partition key. Okay, this is the main key that you are always going to use to query the data. And the second one is the sort key. This one is it's a auxiliary key. I can tell it like that because it's going to help you to filter the data according to the partition key. Okay, and the others are basically just attributes. As you know, NoSQL designs are extra flexible, super flexible, so you can place there whatever you want. So when you first start to doing the design, you're going to do a lot of try and error until you decide that the design fulfills your requirements. So just to make an example, I have come up with this design. We have basically a partition key, and we are going to be using also a sort key. Okay, so for example, my partition key here is going to, for the products table that we have here in our entities, we have the products, and it's going to be related, as you can see, with many quotations, and it also has the make and relates to the category. So it's one-to-many relations. What we do to solve is, as I told you before, we're going to pre-join this data. So what we are doing here is to get a product. I have the product with the product ID. A good practice is always to add into the partition key or the sort key always an identification of what you are storing there into the keys. because it makes it a little bit more readable. Because you can see that this is going to get crazy. Yeah. So we add the product and the product ID, so we can fetch the product by ID. So it fulfills this with no problem. The next one would be to get the next would be to get by make and by category. Okay. So what we do here, as I told you, is pre-join. So we have the make with ID and the category. So what is this? Why are we joining a couple the two entities here? What this is going to do is that it's going to let us to query or filter on cascade. So for example, I can say my product ID, search the product ID, and then by the sort key, check that it includes make, for example, my car make. Okay, so you get all the products of my car make. That's it. And the second one would be get me the product ID by the make, and if it includes category of ROAD, for example. So you can get all the products that are of that make and that category. And it gets really easy when you start to understand it. The second one is basically the category. So I have my category, my ID, and the make. So here I can check by category ID and by the make. The make as well, I can check by the make ID and by all the makes. Why? Because here in the sort key, I am adding the word make. So I can check, please get me all the partition keys with the word make. So you get all the makes. Let me show you that right now. How we can do that is because in single table design, we have these helpers that are the global secondary indexes. You also have local indexes and stuff, but I'm not going to be explaining that because you can check that later with no problem. So what I can do here is to create a secondary index to revert the partition key. So now we have, as you can see here, the global secondary index. The partition key turns to be the the sort key, and the sort key turns to be the partition. So I reverted. It's a methodology. So here I can get all my makes and, for example, all the clients. So it's really useful. And finally, for the quotations, the same. Basically, this is going to be resolved with global secondary indices, because here, as you can see, we have like quotation and clients. So once we add another client, we are going to be able to get in the global secondary index one all the quotations of the client and vice versa. So it's really useful, and as you can see, we are using only one table to solve all these access patterns that we defined. I also defined that global secondary index number 2, which is basically going to help me to solve the access pattern to get the quotations by status and by date. The global secondary indexes, you can check, you can see that you basically choose which is going to be your partition key and your new sort key, and you can use it with any of the attributes that you are going to be defining here. And the last global secondary index that I defined is the client name, because I need that report to get all the clients by name. Okay, so that is pretty much it on our single table design. As you can see, this is going to be totally useful for the application. We're going to be using only one table to solve all the patterns that we need for our project. And now let's get to the important part. How is TypeScript going to help us to solve, to work better with the single table design? Basically, with this design, the attributes and the table names and everything that you knew about relational databases are gone. I mean, before we used to check like the entity, I don't know, like cars, and you have the color, the image, the specification, then you have the other entity that could be client, the name, and stuff like that. But here it doesn't exist. The only thing that you are going to be uploading to the NoSQL, the schema, is going to be your partition key, your sort key, and the global secondary indices. So that is what your NoSQL schema is going to know, nothing else. So when it starts to get a lot bigger, you are going to be able to see that it is going to be unreadable. The table is not going to be human readable if you go to your NoSQL schema and you check it, and you're going to see a lot of attributes mixed with all the tables, and that is a good single table design because you have it all in one table. Also, as we said before, we don't have defined any structure and everything is so flexible, so we need a way to control that in our project, in our code. We're going to have to keep up the schema aligned with the database, the backend, and the frontend to be able to work, because otherwise, if you don't know which table has this primary key, partition key, and which attributes in the front end, how are you going to pull those attributes? It's going to get messy. So TypeScript is going to help us a lot to work better with the design. And yeah, just to give you an example of how this might look with more data, you can check it here. Let me open a NoSQL workbench for play a little bit with it. So I was let me select the model. I was doing the model a little bit earlier. So here we can see the model that we made with a lot more data. So this, as I told you, this starts to get a little bit weird and unreadable. But if you start checking it, for example, with the global secondary indexes, you can check that it works. So for example, I can get all the clients with the client word, and here it will retrieve all my clients here. Okay, the same with the client ID. I can get all the quotations that the client did. This one is the client 2, has this quotation. The client 1 has 2 quotations. The same happens with the make and the category, as I told you. You can get the products from that. And in the number 2, you can get the available products. You can get the quotations that are onboarding or sold. And you can also get the products and the quotations that were made for that product. Okay, so as you can see, everything is pre-joined. Everything is reflecting into the global secondary indexes, and you're going to be able to get the data super efficient. Awesome. So now let's start with our project. Okay, we are going to be using AWS Amplify. I like to use it because it's really fast to start a serverless application. So to do it, let's just write Amplify init. This will start the application, asking you some initial parameters, the name of the project, the environment, which you can add dev, staging, production, the editor, because it uses some configurations for the editor, the programming language we are going to be using. I'm going to choose JavaScript. Doesn't have TypeScript by default. And we are going to be doing our frontend with React. Okay. The source directory, these are basically the configurations for the front, and we will see how it works later. Okay, and that would be pretty much it. So CloudFormation is going to start making all the configurations needed according your AWS profile. Okay, that is done. So basically created all the project. Here is showing us that we can add an API, we can add storage, we can push to the remote, obviously, to the AWS, to publish everything that we've been doing local to AWS. But right now we are going to be creating our API, so we just amplify add API. This is going to create as our endpoint, and we are going to be able to create the rows. You can add as many endpoints as you want with Lambda functions, with triggers, with many different languages. We're going to be using Node.js, and we are going to use the serverless Express.js function. Now let's add our storage, which is going to be our DynamoDB single table schema. Let's choose NoSQL database. Okay. And here's going to start asking for the names and all the configurations, but especially for our database schema that we defined prior. Okay, so it's going to ask us for the name of the table, the columns. So here we add the partition key, the sort key, and all that stuff. So I'm just going to move forward to this to start coding. Okay, so we're going to be checking what Amplify generated for us. First of all, we have the VS Code settings that generates for better writing. We also have the git ignore with all the folders that we want to ignore and do not push to our repositories. After that, we will have the source folder, which is the front-end folder. Here we will add our React application, and as you can see here, we have generated an AWS exports file. This file basically get us all the information and tokens that we need to automatically connect to our frontend. What our API, our storage, our authentication. So this is basically auto-generated, and it helps us to use it in our frontend. So for example, here we have our API and the endpoint that we have created. Okay. Next, we have the Amplify folder, which is the backend folder. Here we are going to be working on creating the function to for our API. Okay. Also, we have the auto-generated configuration for the API, for the storage. We are going to be able to see here what we set it up for the database. So here, for an example, I just set it up the partition key and the sort key to start testing. We also have the other files, the templates that are going to help us to migrate our project from one place to another with no problem. And finally, we have the function folder, which is the one we are going to be using. As you can see, this folder is the one that we are going to that Amplify is going to be using, and the source folder is where we are going to be writing our code. Okay, Amplify generates examples of the Express application in JavaScript because it doesn't support TypeScript by default. So we basically don't want anything on this folder. So I guess I'm just going to go ahead and delete the folder, and we are going to start our TypeScript configuration. Okay, awesome. So first of all, what I like to do here is to create a new folder called source ts. Why? Because this is going to compile into the source folder, because Amplify only gets that folder, okay, the source one. So here we're going to start our TypeScript configuration. So let's create a new file, tsconfig.json. Okay, so I have a previous generated configuration that we are going to check. So what we have here are some TypeScript parameters that I'd like to set up. First of all, we have the modules, the target, no implicit any. For example, the outdir is going to be the source to get everything compiled into the source folder. Always allow strict null checks. And here we have a cool TypeScript feature, which is called contracts. Okay, what this is going to let us is to share and keep aligned our types from the backend and frontend. Okay, so that we can use our types in our full stack project without a problem. Okay. After that, we have some plugins, and we obviously want to include the source.ts folder and exclude the node modules. Okay, that will be our TypeScript configuration. After that, I'm going to be creating our npm project. I already have a setup package.json for our package.json. So let me copy it. Perfect. Let's dig in a little bit more here. What we have are basically the AWS dependencies that we need. We have .env for environment variables, JSON schema to let us control the schema that we're sending to Dynamo, Express UID to create the IDs for the products that we're going to be making the example of. All the types that we need. Copy CLI is going to help us to move some things to the source folder once we compile, TypeScript obviously, and a couple of important scripts which are compile to copy everything from the node modules to source. Then we will want to copy all the JSON files, and finally compile the source folder. Okay. After that, I created a deploy command. So what it would do is basically compile and then push our application to AWS. Awesome. That will be it for here. So just let me install really quick our dependencies. Okay, CD amplified, so on, hello CD. Perfect, npm stuff. Okay, this will take a little bit, so I'm just going to go ahead and forward. Okay, so I've written some previous code to start checking how the project is going to work. I've made the folder configuration. As you can see, we have the APIs, the config folder, some constants, the contracts for the types, the models to get the data from our DB schema, and the services. So we're going to start, we're going to make an example with the products API. Let's start with it. So here we have basically normal stuff. We just start getting all the paths, get all products, get products by ID, post, ID, delete, and normal stuff, okay? But let's start digging in a little bit more into the service. So for example, let's check the get product by ID. What we are sending here is basically the query that is going to get our make and category, and the ID is the ID of the product. Okay, so what do we get here? We basically have the product ID, which is the string, and the product query, which should be the make ID and the category ID. Okay, so we are controlling that. Now, when we start checking the query, we validate that it fits the schema to get the product. So what we do here is to check if the schema finds the make ID and the category ID, because as you remember, it was necessary to get these keys to be able to retrieve a product with the partition key and the sort key. Okay, so we need to validate the keys as well. After that, we're going to check if we're going to get our data from the model. So to get our data, as you remember, we needed, again, the partition key and the sort key. But this was a little bit tricky. Let me show you in the SQL design. So here we have our partition key, which is product hash and the product ID. And the sort key is make hash the make ID plus hash category hash the category ID. This is made, as I told you, so that we can start checking with queries like begins with or contains that, and it'll make our lives easier to separate it with this. But as you can see, how do we control that this model of the string maintains? Because we can send whatever we want. And here is where TypeScript starts to take place. So I can make, as you can see here, I can make a sort key condition type. Let me show you here in the contracts. Okay, let's check our sort key. And here we can see, for example, for the partition key, I would like to have a generic that extends the string. So if it is a string, I can say that the partition has to be exactly what the entity product is called, hash the string, which will resume to product hash and whatever ID we place. Otherwise, it's going to present us an error. So this is really important, because otherwise we might be sending whatever thing we want, or just the product ID, forgetting that we have to send the hash and stuff like that. So this starts to help us a lot to control how we make the queries correctly to our database. So for example, if I only say the key, is going to show me the error because it has to maintain this pattern. Okay, so let's return it to the function. The function, what it's basically doing is exactly that, adding the hash to the product entity with the product ID that the user sent it to us. So we have the same for the partition key, and for the sort key we do exactly the same. We made a condition here with a couple of generics, and we add the product, the make, and the category. So it is controlled, and this is going to help us here and also in the front. Okay, that is one of the main benefits to start working with TypeScript, that we can control these patterns that we create in our design. Because as you can see, we're going to be using it a lot, like in category, in client, here, and also we can make a composite global secondary index that compose from status and date. So we want to be controlling that to be able to send the data and retrieve the data correctly. That is one of the main benefits of TypeScript here. Okay, so basically the next part that we do here is we go to the model and get it from the database. So what it's doing here is checking the partition key, secondary key, the table name, and this will return us the Dynamo product. Okay, but if you think about it, the Dynamo product might return us some data with these hashes and this stuff, and a user that an API user that doesn't have an idea of what the single table design is, or what Dynamo is, or NoSQL or Mongo, they just want to see the data well structured as a JSON. So what we do here is to clean the data. So I have made a function here called cleanup product. Okay, and this is going to get the Dynamo field set or the product that we retrieve from the database, and we return the product data. The product data is composed from the product IDs, which are these ones, the main ones that we need, and we also are going to be using these for queries and stuff. That is why I separated this, and I can make a join with the product content, which is going to be this one. Okay, so in the cleanup, I generate only the information that I want my user to see. So here I just made some replaces with the entity product, the hashes, and just return what I want the user to see when they use my API. So this is really useful. And if you think about it, if we are using this in the contracts, we already have into the product data all the data that the database is sending us. So if we want to use it in our front end, we just have to call this type, and we will have all the type safe parameters of this product entity. And that's it. That's really cool. We will be checking how we can use that in the front end. It's really quick, but as you can see, it helps us a lot to maintain our API. And that's it. In the success response, what I am doing here is basically to send the clean product. If it doesn't exist, I just send a null one, and the response will handle it how it shows to the user. So that's how TypeScript helps us. As you can see, it structures a lot the single table design. Maybe just to give us a bit more of idea, we can check the edit function. The edit function is a bit more different. I wouldn't say difficult, but different to use in the single table design, and especially here just in case if you want to use Dynamo. Why? Because let's check. Here I validate the schema, I get the keys from the query, normal stuff. Here I get the product, still the same as the other one. If it's not found, I just return not found. But if the product actually exists, what I am doing here is to create the parameters to update. This is a new function that we are going to be using. And what is this for? Let me show you. So Dynamo basically lets you update the parameters with a different setup. You need to first tell them what are the param keys that you are going to update in a collection, and in a second collection you need to send the values for those parameters according to the index. So for example, let me show you here more or less how it might work. Okay, so we have param1 is going to be name. Param2 is going to be, I don't know, price. Okay, and the second collection will be param1 car, and param2 $1,000. Okay, that is how we need to send this. So this one is a little bit difficult, but just using a couple of functions, we are using here a functional reduce. So we basically do a reduce. We start with the accumulator, we start with set, and we are going to concatenate all the parameters according to the index and adding the key. Okay, and the same goes for the param values. So this is kind of difficult to understand at first, but once you have these functions, you can use it for all the entities that you are going to be working on. Okay, and yeah, that will be basically it for the backend. As you can see, the types are really easy, and it saves you a lot of time for the single table design. So let's continue with our front end. We're just going to check how easy it is to use the contracts, and let's go. Now in the front end, I've made a React application with Webpack. So it's this is normal stuff. We have the Webpack, we have our TS configuration for the React application, and as well as you can see here, we are using the contracts, we are including the source, the tests, and just in case, you can see that I recommend you to use Slint, to use Prettier, because it makes your life a bit more easier. Especially when writing code, it saves you a lot of time, and it makes your code a lot more readable. And let's continue with our TypeScript setup here. So we have basically, I'm going to show you the how we use the API that we have made. Okay, so we have here our services, and I have created an API abstraction so that all the requests that we made already have the configuration that is needed and the products API. Okay, so the API here, as we are using Amplify, we just use this API from the AWS Amplify SDK. So it's really simple. You just get the API and start using it as normal as any other request. Here you can include configuration, you can include the headers, you can include the token for authentication. I have disabled this because we are not using authentication, but if you use it, it's really easy. You just add here the header for the token. And that would be pretty much it here, and let's see how we use this API in the products. Okay, so we basically start calling the products paths and stuff, as you can see. But an interesting thing is that we are already using the contracts. So as you can see, we are getting the product data and the product IDs that we were using in the backend to be used in the frontend. So I get the query according to the product IDs. I need to get the product ID, the make ID, and the category ID according to make this thing work. So as you can see, it's really useful. We already have type safety for making the requests according to all the C or the CRUD operations. Awesome. And the same goes for when you want to use the information that the API returns. For example, I've made one page to show all the products. So here we have the grid, and we make a map from the products here and the products row. Okay, so here we can see that we are receiving the product as a product data, which is the one we defined in the contracts before. We have all the IDs and all the content of the product. So here, for example, if I render now, I'm going to get the product category ID, the make ID, and that'll be pretty much it. So if I render, it'll be looking like this. I have the category, the name, and the operations. So if I want to keep adding more data, it's really simple. You just hit the dot, and you are able to get all the information from the data. We can keep adding the name. We can add for example, the price, which is really important for the quotations, and we can add, for example, the year and all the data that we have here. As it is type safe, for example, if I write a boolean, I can make an assertion, super simple. If it's disabled, say, for example, not for sale. If it is, okay to go, something like that. And that's it. So as you can see, it's really easy to use the contracts to keep your types aligned in your full stack project in the backend and frontend. So that way we can get, as you can see, we still are having all of our data being retrieved here. And if you want to make a little bit more tests, we can check, for example, in Postman, I made some examples. And here I made the create API without the cleanup so that you can check how it will look. and it is weird. If you see an API and return like PK, SK, and you're saying like, what? But if you start cleaning the products, for example, let's show how it retrieves on the get. You can see that it shows only what we sent to the user without the PK, SK, and any others that you might have, because you can also have another composite keys that you want into the single table design. And that will be it for the presentation, for the workshop. Thank you very much. That has been the workshop about the single table design with TypeScript for the TSConf. Thank you again for watching this workshop. If you are interested in the serverless world, in the single table design and TypeScript, I can also recommend you to check some cool tools that have been made with TypeScript. These are the Type Dorm and also OneTable. These tools can help you a lot to build your project as we showed it today, and a lot faster, and using TypeScript as well. So thank you again, and